Hey, welcome back, fellow scientists. So today we're going to begin our foray into the adaptive immune system or the adaptive body defenses. Just kind of big overarching picture. We talked about blood, we talked about the lymphatic system. We're kind of in the middle of the immune system. We're going to have this video and then probably two more videos. And then we're looking at a test. So be expecting a test probably, hopefully next week Tuesday, maybe next week Thursday on the immune system. Well, on blood and the lymphatic system and the immune system. So here we go. I'm stealing most of this stuff from your book. So if you have your book at home and if you've already read it, this will not be any new news to you. But hopefully, if you read it, this might hopefully put things make things a little bit more understandable or explainable or whatnot. So Shaylin, as always, commented, and she wants magenta pink for a color. So I think I know which one she's talking about. I believe it's that one right there. So we'll go ahead and use that one. So the book starts off with this idea of what the adaptive body defenses are. It's basically a learning immune system. So it responds, it adapts to the environment, and it used this analogy related to clothing. If the clothes in your wardrobe were like the adaptive body defenses, then as your body changed, your clothes would just change right along with you, right? So you remember that my 6-year-old right now, this is his favorite shirt. This is not, a photograph of his favorite shirt. His is a lot more stained and ripped and dirty or whatnot. But this is his exact favorite shirt. And if he had it his way, this shirt would heal itself, right? And it would grow as he grows, so that he would never have to hand it down to his whatever's left of it to his smaller brother, right? So that's kind of like the adaptive body system, the learning immune system. Like as we encounter new viruses and new bacteria, and as things change in our lives, then it learns and it changes with us, which is kind of cool. So a little bit of history, and I think when I read this, this helped me to understand kind of the two arms of the adaptive immune system better. So the way that people first found out about this is they took a sick animal, right? And that sick animal usually got better, but then rarely would that animal get sick with the same thing, right? So once it was sick, like we know this, well, I know this, you guys have the chickenpox vaccine, but I got chickenpox when I was a kiddo. And I just had him once, and I never had him again because my immune system learned to deal with that invader, right? So they found that out. They also saw, you guys remember the composition of blood, right? So they also saw that if you took plasma from a sick animal and you injected it into a healthy animal, then that animal wouldn't get sick. It had never been sick before, but there was something in the plasma that made this animal resistant or immune to the future infection that it might encounter that this animal actually had. So that's kind of one branch of our adaptive immune system, and that's called the humoral immune response. Is it ALHUMOR? Yeah, AL. So humoral immune response. Humoral simply means liquid or fluid. And you'll remember, right, if you remember back to chapter 10, you're hopefully putting two and two together, right? What's in plasma? Well, we have various nutrients, we have various gases, but most importantly for us, we have antibodies. Antibodies are part of the humoral immune response, okay? They also found out that if you took blood from an animal who had been sick or who was sick, and you took out the lymphocytes. Yep, I got that word right. Lymphocytes. So that's a type of white blood cell, right? So right here, if you for some diseases, right, just transferring the plasma, that worked. That inoculated them against those diseases. But some of them that didn't work. For some diseases, you had to take out the actual lymphocytes and put them in. And then that same thing would apply, that the healthy animal who had never been sick from that disease wouldn't get sick from that disease. So that's our second arm of our adaptive immune system, and that is called the cellular response. Cellular response, because it requires lymphocytes, which are a type of white blood cell. All right, sweet. So that's a little bit of the history. So now what we're going to do, these next couple slides, we're going to look at the cast. So cast of players. We already talked about this, but I just want to go back and very briefly highlight this again, because if you don't understand this, you're going to be up a creek without a paddle. So antigens, right, are these things that are on the cell surface, and they can either be self, right, or they can be non-self. Right? So self antigens, if you have type A blood, you have A antigens on your red blood cells, and a type B antigen would be non-self, right? So for different people, our self and non-self. For most everybody, self. For most everybody, bacterial antigen or a viral antigen would be non-self. Everyone recognizes that, but that's antigen. And then, of course, antibody are these Y-shaped things right here that are proteins that kind of bind to the antigens if they're the right size and if they're the right shape. So let's see, non-self. Sorry, I'm looking at my notes. Oh yeah, that's right. And then this is kind of cool. There's something kind of similar, kind of related to antigens and antibodies, and that's called a hapten. Hapten. So hapten is a small molecule that by itself, it does not create an immune response. Oh, and that's another thing that we should put. These antibodies, these stimulate an immune response. So we'll just abbreviate it IR. These stimulate an immune response, or they're able to stimulate immune response rather. Hapten is a small molecule, that by itself does not stimulate an immune response. But if we have a hapten plus a self antigen, some self antigens, hapten plus some self antigens, that does lead to an immune response. And the example that your book gives is if you're allergic to penicillin, right? Penicillin is known as it can be in one sense of the word considered a hapten, right? It's an antibiotic, obviously, but it can also be classified as a hapten because it's a small molecule that if you're allergic to penicillin, if you have those antigens bind to the hapten, and then they'll create an immune response, which can be deadly, unfortunately. All right, so part of the cast is antigens and antibodies. All right, next part of the cast, we have our different types of lymphocytes. Right, so we have our B cells and our T cells. And this is something I didn't know before reading your book. I knew there were B cells and T cells. I knew what they did, but I didn't know where their names come from. B cells are lymphocytes that mature in the bone marrow. And T cells, right? So B, bone marrow, B cells. T cells are lymphocytes that mature in the thymus. Right, so T cells, thymus. Cool. Now, what do I mean by mature? Mature means that they are able to evoke an immune response. Able to evoke immune response. Perfect. Can reduce each B cell. Oh yeah. So each of these cells, you have millions and trillions of cells, lymphocyte cells specifically, but each B cell can only respond to one antigen. So each B cell, each T cell, each B and T cell can only respond to one antigen. So you have a set of B cells and a set of T cells that will respond to pneumonia, Streptococcus pneumoniae, right? You'll have a set of B cells and T cells that will respond to the common cold. right? If you've been infected or exposed to Ebola, you have a set of B cells and T cells that will respond to that. If you've been infected or exposed to COVID-19, you'll have a set of B cells and T cells that will respond to that. So they're like one B cell can only respond to one thing, but you have many different types of B cells. One T cell can only respond to one thing. You have many different types of T cells, right? So this is interesting to note. Each B cell and T cell can respond to an antigen before actually encountering it. So that's why I have this picture. We'll just go ahead and scroll down. I left myself too much room down here. So each B cell, each B and T cell can respond to an antigen before encountering it. Sorry, my handwriting is horrible. It's not my fault. It's the writing pad that I'm using. So that's kind of interesting to think about, right? What does that mean that our immunity or our immune system is based on? How does the B cell and T cell know how to make those antibodies to respond to the antigen? Well, you guessed it, DNA, right? So immunity is genetic. Immunity is genetic. Immunity is genetic. All right, and then last but not least, hang on one second.